Hello everyone. So as in continuation with the last video on exercise 1.1, I am continuing with the next question, that is question number 4 now. Question number 4 says that use Euclid's division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m, right? So you have to use Euclid's division lemma to show that square of any positive integer is of the form 3m or 3m plus 1, right? So let's see, let x be a positive integer. So by Euclid division lemma, we can say that x is equal to 3q plus r, where your r is either 0, 1 or 2, that it lies between 0 and it is strictly less than 2. And here we have taken your b to be 3. Okay, as per the question, whatever is asked in the question, you take that value of b, right? So now you have to show that this is of the form this, where r lies is 0, 1, 2. So he is saying that square of this number, this is the number, we have to take the square of this number and we have to see the square of the number. After taking a square, we get either form 3m or 3m plus 1 and not any other form, right? So we'll take one by one. Let r is equal to 0 first. So your x will be 3q plus 0, that is your 3q. Now squaring both sides, if you take a square of a number, we get square of a number means x square, whole square, and this side 3q whole square. So if you open the square, it will come out to be 3 3s are 9q square. And if you take out 3 out, you have 3q square in the bracket. And if q is a integer, so obviously q square of an integer is an integer, and multiplication by an integer is also an integer. So this means that inside number, this bracket number, if we take it as m, let this is m, so this is equal to 3m, where m is equal to 3q square, which is again an integer, right? All the properties of an integer, right? So therefore your x is, the x square is of the form 3m in the first part. Okay, now this is the first part. Let's see the second part. Let now your r is equal to 1. So now if r is equal to 1, your x is equal to 3q plus 1. So now again squaring both sides, what do you get? X square is equal to 3q plus 1 whole square. So that means it is 3 squares. The formula of a plus b whole square is 9q square plus 1 plus 3 2s are 6q. So in these two, if you can see, in these two terms, your 3q is common. So it is 3q plus 2 and this 1 is left outside, right? Now if you take this bracket with this q as m, so you have 3m plus 1, where your m is q into 3q plus 2 is again an integer, okay? Because integer follows all the properties under multiplication, division, addition, subtraction, right? So this is also an integer. So this is of the form this. So therefore your x square is of the form 3m plus 1 in this condition. Now if we see the third condition is when your r is equal to 2. So now let r is equal to 2, so x will be 3q plus 2. Now again squaring both sides, we get x square is equal to 3q plus 2 whole square, right? So this is equal to, again square formula we'll open, so 3q square is 9q 9q square plus 4 plus 12q, 2ab, right? So if you'll take out 3 common, you can break this 4 as 3 plus 1. So we have written this 4 as 3 plus 1. So you can say 9q square plus 3 plus 12q and this one outside. So in these 3 terms, if you take C, 3 is common. So it is left with 3q square plus 4q plus 1 and this one outside. So this whole bracket if you take as m, so it is 3m plus 1. Again where your m is 3q square plus 4q plus 1, which is again an integer. All the properties of an integer. So square of an integer is integer, again multiplication integer, addition with an integer is again an integer. So this is again an integer. So therefore your x square is of the form 3m plus 1 in this case. So in the first case it was of the form 3m, in the second case it was of the form 3m plus 1, and in the third case it is of the form 3m plus 1. So therefore we conclude that square of a positive integer is always of the form 3m or 3m plus 1 and not other than any other form, not any other form, right? Now see this question number 5th, the last one. I am going to give you a hint of this question. On the similar lines, the same question is there. Here we were doing square of a number. Here we need to do a cube of a number. So he is saying use Euclid division lemma to show that cube of any positive integer is of the form 9m, 9m plus 1, 9m plus 8. So let again your x is a positive number. So your x will be of the form 9q plus r now, because we need the answer in the form 9m, 9m plus 1 and 9m plus 8. So we let your b is equal to 9. Therefore by Euclid division lemma your x will be 9q plus r. Okay, and where your r can be 0, 1, 2, 3, 4, 5, 6, 7 and 8, because it is still 9. Your b is 9. So that is your r lies between 0 and strictly less than 9. Okay, so this was the condition on r. So you have to put the values one by one and you have to take a cube of a number. So I'll show you one part. Let your r is equal to 0, so your x will be 9q plus 0. So now we need to cube a number. Cubing both sides, we get x cube is equal to 9q whole cube. So this is 9 into 9 into 9 into q cube. So if you take 9 outside, because we need the answer in the form 9m, 9m plus 1 and 9m plus 8, any of these forms. So we'll take 9 outside, so you have 9 9s are 81 q cube. Again this bracket is an integer, we take it as m. So this is 9m, where your m is 81q cube, that is an integer. So therefore this is of the form 9m in the first case. Again now let r is equal to 1. Okay, so you'll do this with the r is equal to 1. So your x will be 9q plus 1. So cubing both sides, again you have x cube is equal to 9q plus 1 whole cube, right? So you will take the cube of a number, so that will be 9q whole cube plus 1 plus 3 into 9q plus 1 into 1, 3ab into 9q plus 1, a plus b. This is the formula, right? So this you will apply and you will see that it is of the form 9m plus 1. So you'll do this with the other cases also and you'll see all the forms come in these 3 forms. So therefore we have the answer, right? So if you need more explanation on these questions, you can write me in the comment section and I'll give you again more explanation on these questions, and we'll move on to the next exercise in the next video. So keep watching, keep liking and keep subscribing. Thank you.